All right, so yesterday we looked at triangles, and what we were given were two angles and a side typically. So this, when you're given angle, angle, side, we used the law of sines. This one, angle, side, angle, we use the law of sines for this as well. Now, just to remember, law of sines is A over sine of A equals B over sine of B, which equals C over sine of C. So this is what we worked on yesterday. All right, today we're going to look at number 3. This, number 4, is side, angle, side, and that's going to be law of cosines. And number 5 is side, side, side. That's also going to be law of cosines. And we'll be looking at that the next couple days. Number 3 is what we refer to as the ambiguous case, because there's a couple different things that can happen with this. So this is referred to as the SSA, or the donkey case. And you are usually given angle A, side A, and side B. And those should always be your flags, that this is the special case that you need to pay attention to where different things can happen. So, angle A, side B, special cases. Alright, so what happens is we trust that when we're given measurements, a triangle is going to be formed. But when we're given angle A, side A, and side B, it's not always necessarily that a triangle can be formed with the measurements that are given to us. Also, sometimes there's a case where two triangles can be formed by the measurements that are given to us. So, what we do is we check the relationship with length A and length B. If A is less than B, then there's no triangle, usually. Then we're going to check the relationship with A and H. If A is less than H, then there is for sure no triangle. If A is greater than H, then there's two triangles that can be formed. And this is how we check for H. So now let's look at how we can check these things. Because right now your mind's probably not quite sure how you can make two triangles, but we'll look at it in just a minute. All right, so example 1. We have angle A is 85 degrees, A is 15, B is 25. So quite often you'll want to draw yourselves a picture. You don't have to if you don't want to. You can look at what's given to you. So we know that A is less than B. So we think that there's no triangle formed, but we need to double check. And what we need to check is the value of H. And H is equal to B times sine of A. So our B is 25 sine of 85. So that gives us 24.9. Since H is greater than A, there is no triangle formed. And that is because of the rule that's given here. If A is less than H, then there's no triangle formed. And you can find this in your textbook. And you might be able to read it a little bit better. That's in your textbook. All right. Example 2. We have A equals 42 degrees, A equals 22, B equals 12. A is greater than B, so we have that one triangle is formed. So if you want to draw yourselves a picture, you can. A is 42, A equals 22, B equals 12. So we need to find B, angle C, and length C. So now that we know there's one triangle formed, we're going to use what we learned yesterday with the law of sines. So first thing that we can do is find B. Using law of sines, we have 22 over sine of 42 equals 12 over sine B. Don't forget you have to do the inverse on this one. And B is equal to 21.4 degrees. So that's this. C is easy to be found. 180 minus 42 minus 21.4 gives us 116.6. Now the last thing that we need to find is length C. So we have, use your values from A because those are given. So 22 over sine of 42 equals C over sine of 116.6. And then we find that C is equal to 29.4. All right, example 3. So most of you are probably anticipating that this is the worst case scenario since it's the last one. So you have angle A is 20.5 degrees, A is 12 degrees, B is 31. So A is less than B, so we think that there's no triangle. But we need to check H. And H is equal to 31 times sine of 20.5, which gives us 10.9. Since H is less than A, two triangles can be formed. And let me show you how this happens. So we have this is our original triangle. This leg gives us the original triangle, but when we move this leg, when we swing it, it's got just the right distance so that it can form another triangle. So this is our first triangle that can be formed, and then when we swing the leg, we have the second triangle that's formed. So it's just a matter of moving the leg from outside in here, and it just so happens to hit this bottom leg just right so that it can form another triangle. When it swings, there is an isosceles triangle that's formed in here. We don't need to know the dimensions of this, but what's important to know is that this measurement, when you're looking at the original green triangle, is the same as this because you have an isosceles triangle. Also on an isosceles triangle, once we find this measurement for the original first triangle, this angle measure will be the exact same because on in an isosceles triangle, the two bottom angles have the same measure. So then it will make it easy for us to find the measure of this angle. So it swings around nicely, and it's not that difficult to find the missing angles and lengths. So now, let's start with our leg originally extended out. So draw yourself a picture, and that looks like an equilateral almost, but it's not supposed to be. So this is 20.5, A is 12, B is 31. So we're going to use the law of sines to find B and C, and then little length C. So we'll do, we have to find B first, and I'm going to refer to this as B1, C1, and little c1 because this is from the first triangle. So B1 is found by using law of sines. 12 over 20.5, we need the sine of this, equals 31 over sine of B1. Doing our computation, we find that B1 equals 64.82. We can then find angle C easily, 180 minus 20.5 minus 64.82 gives us 94.7. Then to find length C1, so that's a little c1. We use the law of sines again. 12 over sine of 20.5 equals c1 over the angle that we just found, 94.7. That calculation will give us 34.15. All right, for the second triangle, what happens is the leg swings in. So it was originally extended out here. It swings in. This creates, and it doesn't look like it, an isosceles triangle. So we have the same length here that we had out here. This is 12 still. This is 20.5. This is still 31. Now, this was a measure of 64.8. So that means that this other interior angle is 64.8. So that means that finding angle B, so for triangle 2, so this is B2, it's as simple as 180 minus 64.8 because the two angles are supplementary. They total 180 degrees. So that gives us 115.2. Then to find C2, all three angles total 180 degrees. So 180 minus 20.5 minus 115.2. So that gives us 44.3. And then the last thing that we need to find is little length C, and we use the law of sines to find that. So we have 12 over sine 20.5 equals C2 over the sine of 44.3. And that calculation gives us 23.9. Now, there's some cases that you have to pay attention to. If you have A and B are the same and angle A is obtuse, there's no triangle formed. If A is less than B and A is obtuse, there's no triangle formed, so that's something else that you need to pay attention to. If they're equal, like I said, and A is obtuse, that can't form a triangle. So pay attention to these 6 specials. These first 4 refer to an acute. These 2 refer to an obtuse. Because there's one in your problem set where you're going to believe that you can do the 2, but your angle A is obtuse, so then it won't work. All right, good luck with it. If you have any questions, let me know.